Wow, it's exciting to meet each other in person outside the Zoom. So how many of you heard about micro-frontend approach? But how many of you are actually familiar with this approach? How many of you at some point wanted to adopt this approach to your teams and thought like, wow, this is probably cool? And we're looking for some best practices all over? And how many of you actually found them and ran into some unexpected challenges on the way, some blockers even? And maybe even thought, will the effort will be worth it? Why am I doing this in the first place? So hello and welcome to my session about how React Micro Frontend reshaped our dev forever, based on our real story. I'm here to give some answers to help you understand if you even need to consider adopting this approach, and if you do, to convince you why it will be worth it to make this effort, to make it happen. And most of all, to help you get prepared by knowing all the predictable challenges that you're going to have while implementing such a thing or migrating. This is me. My name is Rotem Zifroni. I'm coming here from Tel Aviv, where I live with my awesome boyfriend and my 5-month-old cutest ever puppy. Before my current position, I served in the Israeli army for many years in Unit A200 of the Israeli intelligence. Later on, I joined Wix, which you must have heard of, building one of the powerful website builder platform and actually taking the front-end development to the next level. So it was just natural for me to jump right into Frontegg, where I work in right now, because Frontegg is actually the next front-end empire in the SaaS world. In Frontegg, my day-to-day is built out of endless architecture challenges that we must face in order to fit the market that we're aiming to conquer. And this is why I'm here today. I think we do something pretty unique that's worth to share with you. Let's talk a bit about micro frontend before diving in. So actually, when we talk about micro frontend, we're just kind of taking the microservices approach from the backend to the frontend side. We're talking about how we take front-end application, decomposed of micro application, working loosely together and creating some unified experience to the user. As we can see here, like each of the micro front-end application has its own source control and is fully independent in terms of building, testing, and pipeline all the way to production, where it's taking place in the main application. If we look at the same diagram from the resources perspective, so like we get a structure when each team can work on its independent application and take care of fully end-to-end features in terms of CI/CD, DevOps approaches, technologies, framework, and source control. So let's mention a few of the reasons why breaking things into small stuff is very valuable. So first of all, we get flexible technology choices. For example, one team can choose to work with Vue.js and the other team with Angular, which make life a bit easier. We get scalable development for two main reasons. One of them, we can easily create new teams with new business KPI working on independent new front-end functionality. And on the other hand, we can easily onboard new people, because if I'm onboarding a new developer, he can easily jump in because the code is much more smaller and dedicated to one domain. We get easier maintenance thanks to easier application and code. We get faster deployment because each team is independent for its own CI/CD all the way to production. The deployment is independence, which means that if some team deploy his micro frontend, the main application might not be even affected by this. We can smoothly refactor some part of the code. And in this way, we can always be up to date with latest technology because the effort is not that big. Easier testing, each team and each domain can test his own source code with its own technology. And most of all, we get autonomous teams. Each one is an expert of its own domain. It doesn't necessarily need to be an expert with other domains. But same as every good thing, in order to actually get the value, we will need to work hard. And those are some of the predictable challenges that you will need to manage somehow if you chose to go with this way. So first of all, we have now separated infrastructure. Before we separated things to micro application, so we have one infrastructure to maintain. And if we breaking this, so we need to maintain a few. Second of all, we want to give a unified experience to the user. So we probably will need to use the same UI component in order for the user to not notice that we're doing some separated application. And we probably will not want to implement it every time. So we will need to kind of extract some libraries. The navigation. Most important, we don't want the customers to notify that once he navigated to another page, under the hood, we rendered new application. So we will need to think about how to do the routing. We will soon realize that if we will not manage somehow the CSS, so after all this micro frontend will sit on the same DOM, and we will very soon find some unexpected behavior. So we will need to manage this somehow. Then we talk about shared libraries. We want to avoid duplication. We don't want to import everything one more time and keep the version alignment each time. And then we're going to talk about it a lot today. We're talking about how to share the state, because I'm sure that all of you have your own state management and store of the application. But what happens right now if we have a few applications that need to share the same context? So let me introduce you to Frontegg. This is us and my team. And Frontegg, before everything, we are a front-end infrastructure. We actually live inside our customers' application, and we even are customers of ourselves. And therefore, reality is forcing us to come up and step up with outside of the box thinking in order to be able to support more and more businesses in the industry of the SaaS companies. This is why I'm going to use Frontegg to showcase some advanced solution of micro frontend. So what is Frontegg actually? We are helping SaaS company to focus on the core product by providing them everything they need of the user management level. We developed two components. One of them is a powerful login box, is a multi-tenancy login box that includes a lot of built-in features. And the second one is the admin box, which is helping the user manage every aspect of his account. We sit on top of the user's application without actually interfering their core. And also, we need to be able to be customizable. So the customers will be able to customize our component to match their brand style and the user experience. I'm going to talk today a lot about the login box and the admin portal, which you will soon realize that we need to use some micro frontend techniques in order to make it happen inside a customer's application. So I'm going to use our story, and we will dive in right now. So as I mentioned, those are the three facts that are making the biggest challenge for us in terms of micro frontend. So as I mentioned, Frontegg is embedded in our customer's application, and it must be. This is like on its own a big challenge, okay, to make it happen. And then we talk about framework agnostic, because our customers can develop their application with each of and any framework, and we don't want this to be a blocker for us to support them. And then, as I mentioned before, it's not that we just embed it in the customer's application. We need to share state with it. We need to get some information. We need to share it with the customer's app. And we will soon see that this is a huge challenge. So yeah, we had a long way to go. So let's start with the base point. So at the very beginning of Frontegg, we knew that our client can build over any framework. So we actually implemented an SDK, a library for each of the framework. We started with React, Angular, and Vue. And we implemented a dedicated library for each of the customers. Now, I'm sure you can guess why it couldn't last for a long time. But let me put it right here. So first, it doesn't make any sense to develop every feature multiple times and also like test it separately. We get the problem when we talk about resources. We need to maintain multiple expertise. We need to have a developer that is expert enough writing Vue.js, for example. The delivery is not so good, because imagine that one customer, for example, has a bug, and then we're not sure if the other clients also have it. Is it something dedicated for Vue.js, for example, or something with our core? And most important, it's a never-ending framework story, because what happens if tomorrow I have a new client that's asking for me to support him with Flutter Web, or with Next.js, or even Vite, for example, that's becoming, like very famous? So in our first try, we knew that we need to choose only one framework, keep our core with only one framework, and find a way using micro frontend technique in order to be rendered inside each of the client frameworks. So we chose React, and we knew that we want to keep our core React only and find a way to render it within the client application. We investigated three options. Probably you're known with most of them. So we tried to use iframe. I'm sure that probably there is no one here that actually like to use iframe. But iframe, after all, are very easy to use. And it's actually an HTML document that embedded inside another HTML document, and it's making things like very, very simple and easy to implement. I want you to see the code. I hope you can see it. So actually here, we see how it would have looked like if we use iframe. So you can see that we have a render function that we call it twice with the module name and the container. And the function is actually just creating an iframe tag, initialize it, and putting the source code, which we take from our base URL, and just appended it to the DOM. And then we get two containers, one of them for the login box and one of them for the admin portal, living in the DOM and making some kind of micro frontend. So as I said, why it could work? Because it's simple. Okay, and we get actually a good isolation, because it's actually like kind of two browsers live in the DOM. The isolation in terms of global variable, CSS, and so on is very good, and the communication is unrestricted. Everything is based on window events, and we kind of like dispatching event without knowing who is going to listen. So it is very, very simple and trivial to share the state. The problem is that we get some restricted integration. For example, if we talk about routing, so using the same router for the child application and the parent application will be kind of difficult. For example, if the child application want to just do like history go back, so we cannot do it to the parent. The child have an access to the HTML of the parent, but not to the JavaScript, because each one of them has its own event loop. And when we talk about, sharing state, sharing context, and sharing libraries, it will be very, very difficult. And most of all, the communication is based on the window, which is a public thing, as we all know. And when we talk about Frontegg, we need to share some secure information, same as JWT token, refresh token, and so on. So it cannot work with our situation. Web component. This was the second try. So just out of curiosity, does any of you use web component in your application? Cool. So we call the web component the standard approach because it's something that's getting very common those days. Web components are actually just creating a custom element that we can use inside the DOM and instantiate it on runtime. So if we use the web component in our situation, we see also here that we have the render function that we're creating two custom elements that is getting the tag name. You can see it on the bottom. And a class that extending HTML element and implement a method we call connected callback, which will be called once we appended this tag to the DOM. So here we do it twice. You can see it on the top. We are appended the admin box and the login box to the DOM. And then we use our bundle render method and actually render this. You can see here also that each of the micro frontend is also dispatching an event to create communication based on the window. Web component also can create communication via attributes. Okay, we can listen to attribute that has been changed, and this way kind of like creating the communication. So again, why it could work? Because the communication is simple, because we get independent lifecycle. As you can see here, the browser is not aware of the lifecycle of the component. It's just appending it to the DOM, and then each component managing its own mounting, rendering, unmounting, and so on. We get independent JS technologies because the web component is not limiting us at all. We can have one application built with one framework and the other with another one. Also, the web component have a very rich API that allowing us to do some very cool stuff that we will talk about later on. The catch will be that this is also insecure, so it will not work in our situation. Then we get to the not for beginners approach. We call it the dynamic module resolving, which is actually mean that our main bundle is not including the micro frontend. It's including just the placeholder that on runtime, we're going to retrieve them from the CDN and to initialize them. So this is how it would have looked like. So you can see here that in the render method, we are using the module name and the path, and by REST API, we're actually bringing the bundle from the CDN. Then we call a method that we call connect store, which will actually resolve the global store from the main bundle and add it to the micro frontend JavaScript. This way, we can share the store, and then we just append it to the DOM, and we have our two micro frontend live inside our application. So we chose this way at the beginning. And as I mentioned, the implementation was that our main bundle including the placeholder and the shared libraries, as we just saw. Publishing a new version of each of the micro frontend is just publishing it to the CDN with the relevant version. Our main application is dynamically render the imported micro frontend, and then each of the micro frontend is just a standalone chunk and resolve the store from a global object. I hope this diagram can demonstrate it a bit. So you can see on the left top, like we're writing our code in micro frontend approach. Then we maintain GitHub actions in order to publish our version to the CDN. And on the bottom, you can see the customer's application, the main dashboard, using the Frontex package, and on runtime, downloading the bundle, our bundle from the CDN. So why it could work, we mentioned almost everything, but we can focus on React. We get independent deployment. We extract our shared libraries, which is helping us managing versioning. We get stability of the main repository because it is not affected with every publish to the CDN. We get easy rollback because our customers are just getting the bundle via REST API. So if we have a bug or some production issue, we can just ask by the REST API for another version. Our bundle size is now very thin because it actually doesn't include almost anything. And the micro frontend are fully independent inside the customer's application. It has everything they need, so it doesn't interrupt if the micro frontend is React inside an Angular application. Honestly, the main issue that we had here is context security policy, which apparently a lot of our customers is using. And the problem is that we are actually taking JavaScript from the CDN, but also manipulate it when we connect the store. So this is not working for application working with CSP. And we also get complex pipeline because we're managing a lot of versioning and dependency and alignment and shared libraries inside the CDN. And you can imagine that the hierarchy is getting like very, very complex. And also the delivery was very bad because imagine that our client could have get new version without actually know about it, okay? They didn't upgrade, they didn't do anything, but we update the version in CDN. So it got us in very big issues and very bad experience. So our second try is talking about doing kind of the same, but avoiding using the CDN. So we talk about how we import our micro frontend as an ESM modules. Actually, how it works, the micro frontend is imported using lazy loading as a JavaScript chunk file, thanks to awesome Webpack. We extract all the share library to a main bundle. So like this way, we can use a share context. We can have our React context on the global application. Then the micro frontend include only themselves, and our main bundle including the main bundle, but also all the micro frontend. The benefit of it is that now we enable very nice tree shaking between the child application, but also with the customer's application. We avoid duplication. We have only, for example, one material UI for all the micro frontend, and then we don't need to manage some kind of like clashing between versions. We're sharing the context very easily between the micro frontend, and we keep the version alignment, as I mentioned. And for our customers, now upgrading a version is very clear and nice and happening via NPM. If they want to upgrade a version, they actually need to consume a new version of NPM, which is making the experience much, much better. A small break, what we had so far, we started with a different library for each framework. Then we decided we want to keep the core with only one framework and make it render inside each technology. And then we wanted to avoid using CDN and using ESM modules. Now it's getting more interesting because this is still not good enough. We live in the customer's application, but we need to get a lot of information from the client. For example, you can see here that, first of all, I need to know who the client is, right? Like I need him to provide me like the host that I need to run on runtime. And then we talk about some customization option and a lot of other things that I must get from the application in runtime. As I said, the mission is to be able to get the client choices when we're first loading. So in our third try, we're talking about how we adopt a communication via props injection. So Our other option were using address bar param or Windows event. And as you already know, it wouldn't have worked in our situation because it is not secure. So how are we actually doing it? We're exposing a provider that will sit in the client application and will wrap the application. And then the customers can inject option, multi-framework interface of option that will work for every application and providing us with props. We will soon see how it looks like in the code. Then our provider is initialize an instance of Frontex application with the option as a context that is going to share with each of the micro frontend. In this way, our micro frontend will be updated with every change, even on runtime, which is making us very powerful. This is how it looks like. So we see on the left side the customer's application, providing us options. Then our initializer init a Frontegg app instance that is sharing the context with the micro frontend. The micro frontend is subscribing to the options and then are updating with every change. Let's see how it looks on the customer side. So we will go with the React client. So as you can see here, we are importing the Frontex provider from our NPM package, from our SDK, Frontex React. And then, let's see if it works, cool. And then we are actually wrapping the application with the provider and providing it with Frontex options. Here, I'm providing just the simple properties of the base URL, like who am I? And the theme option, for example, here, I'm just asking for the background color to be in this color. Very simple, right? But this is still not good enough, because right now, I'm getting all the information I need from the customer's app, but actually, I need to share with him my store. For example, here, you can see Frontex Dashboard, as I mentioned before, using Frontegg as a service. And here, this is our application, which I actually need to know the username. I need to know how many days he left with his trial that we're managing in the Frontex service. I need to know his email, his profile picture. I need to know if he is even authenticated or not. So here we're talking about how we share our store with the client application and between the micro frontend themselves, the login box and the admin box. So the mission here, as I mentioned, is to share now the store outside. The problem is that our React customers want to get the access via hooks, but Angular want it by observables and Vue by mixing, and so on and so on. So our fourth try is actually one of the things that we are most proud of. We implemented an adapter for each of the framework. So our store is managed by React Redux sagas, which you probably know. And we implemented an adapter that is responsible to glue our React store to each of the framework. The adapter is wrapping the customer's application and giving them, and providing them the store action. And in this way, the customer's app can subscribe to our event, but also can even dispatch event in our store in order to have their own implementation upon our hooks, which is super powerful. If they want, they can take each and every of our features and implement it by them own using our hooks, action, and so on. This diagram is showing this. So on the left side, we see the customer's application using one of the state adapter, which is built in inside our SDK, Frontex Angular, Frontex Next.js, and so on. Then the Frontex application have an access to the store, and each and every change in the store will be updated in the adapter, and the micro frontend are also sharing the same store. How it looks on the customer side, let's see how it looks for each and every framework. So the React customers will actually import the use auth hook, for example, from the Frontex React, and then we'll be able to see who is the user and if he's authenticated. And then in the application, only if the user is authenticated, I will be showing his profile picture and his name. For Angular user, so we see that on the ng on it, we are subscribing to the is authenticated state and to the user state. This way, in our application, we are also able to see if the user is authenticated and only by then to show the user profile and the username. And for Vue customers, we implemented the function mapAuthState, which once calling here, we're actually making the state available in each and every component. As you can see here, I know if the user exists, and only then I can show his email, for example. So what we had so far started with multiple framework, taking our core to be React only, render it within CDN, then restructuring it to work with ESM modules, and then adding the communication via props injection to get information from the client to Frontegg, and then share our store via the adapter from Frontegg to the client application. We're almost there, but it's still not good enough because, as I mentioned before, we will soon see that if we're not managing the CSS somehow, we might hurt our customers' application. And also, we don't want them to have an access to our CSS. We want to create a smart and advanced API which will let them customize in a way that we choose, and we don't want them, to kind of add CSS important and so on in order to override our component CSS. So the mission here is talking about isolating our micro frontend CSS inside the DOM. In our 5th try, we added a very, very cool API using web component, which calling the shadow DOM. Does anyone here already heard about it? Cool. So the shadow DOM was very powerful for us because it is actually letting us to create a private DOM inside the DOM. In this way, it is becoming very simple. We are rendering each of our micro frontend inside a shadow DOM root. You can see it here. We have the shadow DOM for the admin portal and for the login box. And in this way, we are kind of safe inside the customer's application, and we're not hurting them, we're not interfere some of their UI, and they cannot interfere ours. And now we're good to go. So here I'm trying to demonstrate Frontex Dashboard, which is kind of like a customer's application. As I mentioned, we are consuming ourselves. And then we can see our login box. And once I'm logging into the application, you see that the application now is aware who is the user. We're able to show the admin box with the account settings and everything he needs. And once we log out, we're able to know that the token is expired. And if the user wants to use the application, he needs to log in from the beginning. And now, let me tell you why the Frontegg dev is now having an oasis at Frontegg. So first of all, the dev velocity is so much better. My developers can focus on only one framework, and they're even able to change small stuff in every framework. They can give support because the adapters are very thin and not too they don't need a lot of expertise in this domain. We have independent pipelines. Each of the micro frontend has its own way to production, has its own testing, CI/CD, and so on. And adding new feature is now very simple because we're adding most of the feature to our core application. We implement it only inside the micro frontend, and we're just doing a small adjustment in each one of the framework adapters. The clients are much more happier because, first of all, as I mentioned, the versioning is now very clear and simple, and they know what experience they're getting. Second of all, they get a better support because no matter and regardless what framework you're using, all of the developers and all of the dev success can give you a support. And most of all, adding a new support for a new framework is now blazing fast. It's now very simple to give a support for updated and edge technologies that we find now in the industry. And before I'm ending the session and let you ask some question, stay tuned because we see how the micro frontend is still have a lot of impact of our business. So first of all, we are planning to very soon break our admin box to micro frontend for each of the module in order to improve our performance and our main bundle size. So we're going to retrieve each of the modules only by demand. Second of all, we have now a new team in Frontegg that is dedicated for a new business KPI, and therefore we are planning to break the Frontex Dashboard to 2 micro apps that each one of them will be independent with its own business KPI. And the third thing that we're going to do is we're going to add an option to use CDN, because as I mentioned, the CDN are making the bundle very, very small, and it's overall a good experience. And we're going to do it with hashing, so it will solve our security issues, and all of our clients will be able to use it. So this is on the plan. And that's it. Now it's time for question. Feel free to ask me anything you want. And also you can find me later on if you prefer. Yeah. Just
Thank you. You mentioned something about Iframes. How does this perform when you put them into different web pages?
Sorry, I'm not hearing so good. Can you repeat?
Okay, you mentioned something about iframe.
Yeah.
Okay, I'm putting them into pages.
Yeah.
How does this perform, performance-wise?
How? Sorry,
Performance.
Performance of iframe.
Yes.
So actually, it's a good question. I will need to investigate it a bit more, but I think that our problem with iframe wasn't about performance. I mean, if you implement iframe in a good way and getting the source code is are making a good performance, so shouldn't be any main issues. But I can investigate it a bit more and get back to you with it. Come on, more question. Yeah, here.
Thanks, quite a good talk. Very interesting. One question I had though was if you're mounting separate React applications as micro front ends, do they share the same React root? Are they kind of rendered inside the same application, or are they kind of separate React applications completely?
You're talking about our micro frontend or with the customer's application?
Kind of all together. I'm kind of not sure how it all fits together if you've got separate React front ends working there.
Okay, so actually our micro frontend are sharing the same React root. This is exactly what I was talking about by extracting the shared libraries. So definitely we are creating the React context and the React instance only once, and the micro frontend are sharing it within. But the customer's application will not share the same React root. There are some things that we will share together. For example, the router. Because we have our own React router, but we need to kind of like merge it to your own router in the customer's application. So we do have some method to connect the history or connect the router, but we're going to have our own route.
Cool, thanks a lot.
Hi. At the beginning, you mentioned that you have different teams writing these micro front ends in different frameworks altogether. Do you actually do that? That sounds like a recipe for a mess in organization.
No. So, actually, in our case, we have one team working on it, but the magic is happened because all of my developers are a React expert. Like I don't need to maintain a few expertise, and we can manage this all together inside the team. So no, we don't have a dedicated team for each of the micro apps. But when I talk about, for example, what we are about to do with the Frontex Dashboard, it is about different teams. But I believe that the different teams are mostly should have a different business domain, not about the technology. So, for example, right now, we didn't separate the Frontex dashboard for two micro apps, and we see that the dependency is like very, very tight, but each one of us are working for a different business KPI. So it's making no sense to have this dependency and to manage everything inside the same repo, with the same pipeline, with the same testing, with the same component library. For example, the other team are dealing with some back office stuff and it's some tables and so on. But my team is about like a dynamic editor, builder, and so on. And we even don't share the same component libraries. So this is a good motivation to like separate the application. Is it answering your question? Okay, cool. Any more question? Yeah, here.
Yeah, thank you. Good talk. You mentioned in the middle that you were pulling up the dependencies in the surrounding whatever it is calling you. Is that still the case in the 5th iteration? And how does it work if the calling application can be some random framework? Like how do you extract your React dependencies?
So can you repeat? I'm not sure I'm exactly understand. You're talking about how we extract the shared...
The client application has to manage them, but you don't know the technology of the client application, right? Because you're agnostic to it. So how does that work?
So we're not sharing this with the client application. Like this is the magic. Like we live on top of the client application, and we have like our own dependency and our own context and library and so on. And the client application can share with us if they want to, but they don't have to, because like we just like embedded inside and sharing it with our application, but not with the customer's app.
Okay, thank you.
Sure. Yeah, here.
Hi, very nice talk. Thank you for your presentation.
Thank you.
Regarding the micro front-end architecture, one question popped off my head. How do you do integration tests in...
How do we do
in the integration test? How do you test that your micro front-end will integrate smoothly with the other team's micro front-end?
So, thank you for asking this question, because actually using our awesome architect, we are doing something very, very, very cool. We have one repo for our micro frontend. We have a full Cypress testing that testing our core application. But inside the pipeline, we are actually getting each of the SDK before we even, our pipeline is starting with the micro frontend, and then we have dedicated repo for each of the SDK. So before we even updating in the SDK the version, we are checking once we are inside the micro frontend against each and every one of them. We have a very smart GitHub action that is taking the source code, updating him with the local code of the micro frontend, and running all the Cypress tests against the framework. So
Cypress is like a framework for testing?
Yeah. Cypress is a framework for end-to-end testing. So we're doing it like against some mock, because like we just need to test our UI component. But the powerful thing is that we're testing it local, but we're also testing it against each one of the framework. So once my developer is adding a new feature inside the login box, for example, if something broke with Vue integration, we will know it by then and not only after. So it's extremely powerful.
Okay, and extrapolating to a different use case, let's say I'm building a very large, with many functionalities website and have, 20 micro frontends. Then integration test would be like you take a new version of a new micro frontend, build the entire website, and validate, that the CSS is still black in all the pages, or...
Yeah, exactly. Just like we're taking the main application, like in our SDK, for example, let's take Frontegg. We have an example app which is demonstrating the customer's application, and then the testing is updating the version of the NPM package of the login box and admin portal. And then just like running an E2E testing or unit testing or customization testing or whatever you want to make sure that we didn't break anything in the customer's app. So this is how we do it. And by the way, you know, we need to test some even more advanced stuff. For example, a completely new integration. I mean, you know, for example, let's say that React updated a version to React 18. So we also need to check that when a user is creating now a new, completely new integration with us, so it is also working. So like we're talking about a lot of testing to make it stable.
Thank you.
Sure. Some last question. We still have 4 minutes. Okay, cool. So thank you, guys.